Okay, so now we have our flight time, right? Time sub FL. And it's equal to 2 times the initial velocity times sine theta over g. And we want the range, right? That's our value up here. So we'll plug this up into this quantity up here. So the range, make sure this is on the screen, is equal to the initial velocity in the x direction times the flight time, which is 2 times the initial velocity times sine theta divided by g. All right, but here we had the initial velocity in the y direction, and we plugged in this expression vi times sine theta. Well, here's vi in the x direction. We might as well do the similar type of trigonometric, I should say, argument to get a better expression here, just a more succinct expression. So vi of x is very similar to this. Vi of x equals the initial velocity times the cosine of theta. And you should make sure that that makes sense to you. Right? We're simply finding now the adjacent side, and so we use cosine of theta compared to the initial velocity to get that expression. We're going to plug that into here, and we're going to get the initial velocity times cosine of theta times 2 times the initial velocity times sine of theta divided by everything divided by g. All right, here's a vi and a vi, so we get 2 times the initial velocity squared, and that's divided by g. And that's off the page, there we go. And that's times sine theta times cosine theta. And this is, there's a trigonometric identity that says that if you have sine theta times cosine theta, or sine of something times cosine of something, that's equivalent to sine theta times cosine theta is equal to sine of actually, shoot, I think it's 2 sine theta. I'm not remembering this. Yeah. I think that makes sense. Yeah, 2 sine theta cosine theta equals sine of 2 theta. So this 2 is going to go away. So we have 2 sine theta cosine theta. Right? So we can rewrite this even more succinctly by writing the initial velocity squared divided by g times sine of 2 theta. And I said this in class, but that 2 theta, we don't always draw the parentheses, but you're more than welcome to if you're ever confused to just add in extra parentheses. As you get more comfortable, a lot of times you don't use them as often, but it certainly isn't going to hurt you to add in more parentheses so long as you do them correctly and you adhere to the order of operation. So here we get this expression. I think in your book they may use not, like a little 0, and that's pronounced not, as to be like the initial quantity. You can use I for initial also, whatever you're comfortable with. But that's how we derive the expression for the range on a projectile motion.